So today what we're going to do is we're going to do two types of problems where we solve for logarithmic models. You will have 4 questions that you have to do from this, and then you will have your last lesson, which is on exponential modeling. All right, so imagine you have this problem. Ln of x plus 3 plus ln of x minus 4 is this. So in order to solve this, we're going to use the multiplicative property of the lns. So on the left side, you're going to get the ln of x plus 3 times x plus 4 all over x. Because of the minus sign for the ln of x, it becomes at the bottom of our fraction. And now that we have the ln on both sides, we can drop the ln. So now we get x plus 3 times x minus 4 divided by x is equal to 3. And so now what we'll do is we'll multiply both sides by x, and you end up with x plus 3, x minus 4 is equal to 3x. Now expand the left side, and you're left with this. So you're left with x squared minus x minus 12 is equal to 3x. So now all we have to do is we're going to have to go and solve for our x by moving this over to this side and collecting like terms. So now you're left with, when you bring the 3x to the other side, you're left with x squared minus 4x minus 12 is equal to 0. And so now what we're going to do is we're going to take what we have and we factor it. So now we have x minus 6 and x minus 2. So therefore our solutions are x is equal to 6 and x is equal to, not minus 2, but it should be plus 2, minus 2. So now we have to check our solution in our original equation that we have up here. We have to check the left side and right side. And so now what I'm going to do is I'm going to take all that information and we're going to have it all kind of grouped above our check. So now when you put in for your check of x is equal to -2, when you check the left side of the equation, you're always trying to make sure that it matches with the right side. And you'll notice that when you punch in -3, it's -2, this becomes negative, this bit becomes negative, and this bit becomes negative. And that is impossible. So that means x cannot equal -2 in this case. So now let's go and check the other side. X is equal to 6. So now, when we're checking x is equal to 6, we check the left side of our equation, and we end up with the following. You end up with the ln of 9 plus the ln of 2 minus the ln of 6, which is the same as saying the ln of 9 times 2 divided by 6. So the -6 is here. The 2 and 9 come from here and here. And when you simplify, you end up with the ln of 3, which is equal to the right side. So therefore, x is 6 is our solution. And we're done. So imagine I give you this problem. Either you're going to factor or use the quadratic formula to solve this problem. The log base 10 of 2x all raised to the 2 is equal to log base 10 of 2x all squared. So let's go through the entire solution. And here we go. So the solution is we're going to take everything to one side. So we get 0 is equal to log base 10 of 2x all raised squared minus log base 10 of 2x squared. So now, using our rules for logs, Well, actually, there's an actual pattern in here, and you'll notice you have log base 2 of x and log base 2 of x squared, right? So what we can do is we can drop the exponent on this one here and put it in the front of our number. So you get log 10 2x and then all squared minus 2 bracket log of 2x, and that's it. So now here are our matching parts. We could factor that out. So now we're left with log of base 10 of 2x times the quantity log of base 10 of 2x minus 2 equals 0. So either this bit is equal to 0 or this bit is equal to 0. Okay, so let's just go and explore that, shall we? So now that we have that, we've got log base 10 of 2x is equal to 0. Is that even possible? Yes, it is, because it's actually saying that 10 to the exponent 0 is equal to 2x, right? So 10 to the 0 is 1, 2x is equal to 1, so it means x is equal to 1/2. So that's what we have for our first answer. For this other one, we have log base 10 of 2x is equal to, minus 2 is equal to 0. So this means log base 10 of 2x is equal to 2. So this really means 10 squared is equal to 2x. So now 10 squared is 100 is equal to 2x. So that means x is equal to 50. So now all we have to do is check for both 50 and 1/2, and you find that both of them work. So therefore, you would say your solution set is 50. So you would check just like we did in the past one, but I'm not going to do it this time. And you find out that it works for 50 and 1/2. So you'd say your solution set is equal to the two numbers, 1/2 and comma 50.